Section 8.2 Non-right triangles, law of cosines. In this section, we are going to learn how to use law of cosines to solve for non-right triangles. Law of cosines is used whenever law of sines cannot be used. For example, I have this triangle. I have angle alpha, beta, and gamma, the side A, B, and C. If they gave me the measurement of sine A, measurement of sine B, and the measurement of angle gamma. If I have sine A, sine B, angle gamma, I will not be able to use law of sines because in order to use law of sines, I have to have the pair of the opposite sine with the opposite angle. So in this case, when we have the sine, angle, sine, we will use the law of cosine. Basically, I am given the measurement of A, the measurement of B, and the measurement of gamma. I will use those in order to solve for this sine. So C squared equals A squared plus B squared minus 2AB times cosine of gamma. Now, if I have sine A, sine C, and angle beta, then I will have B squared equals A squared plus C squared minus 2AC times cosine of beta. And if I have sine C, sine B, and angle alpha, I will have A squared equals B squared plus C squared minus 2BC times cosine of alpha. So this is my law of cosines. You can also solve for cosine alpha to get cosine alpha equals B squared plus C squared minus A squared over 2BC. Or you can use this to solve for cosine of beta, which is A squared plus C squared minus B squared over 2AC. Or you can use this to solve for cosine of gamma, which is A squared plus B squared minus C squared over 2AB. Example 1. Find the unknown sine and angles of a triangle below, round to one decimal place. I'm given a triangle with beta is 30 degrees, sine A is 10, and sine C is 12. I am looking for the sine B, angle alpha, and angle gamma. In this particular case, I have sine, angle, sine. I will not be able to use law of sines here. Why? These are all of the combinations for law of sines that I have from this triangle. I have sine of 30 degrees over B equals sine of alpha over 10. This equation, I have two unknowns, alpha and beta. I will not be able to use this to solve for anything. Then I have sine of 30 degrees over B, sine of gamma over 12. I have unknown gamma and B. I will not be able to solve for anything from here. And sine of alpha over 10 equals sine of gamma over 12. I have unknown alpha and unknown gamma. So this is why I cannot use law of sines. I have to use law of cosine in this particular example. In this triangle, I have sine, angle, sine. I will use law of cosine to solve for B first. I will have B squared equals A squared plus C squared minus 2AC times cosine of 30 degrees. This is law of cosine that we are using to solve for B. I am substituting 10 in for A, 12 in for C, 10 in for A, 12 in for C, and 30 degrees in for beta. 10 squared is 100, 12 squared is 144. 2 times 10 times 12 is 240. And cosine of 30 degrees is root 3 over 2. 240 times root 3 over 2 is 120 times root 3. And 100 plus 144 is 244. To solve for b, I will take square root from both sides. When you're taking square root on both sides, they are supposed to be plus or minus values. However, b represents the side of a triangle, and the side of a triangle cannot be negative. So in this case, I will only take the positive answer. And I will put this into my calculator to get my answer. Square root of 244 minus 120 times square root of 3. My answer is 6.0128115,796. And the question asked me to round to one decimal place. So that is 6.0. I found B, 6.012812. Notice that this number is slightly different from this number. Well, the actual answer for B is 6.0 because they asked me to round to one decimal place. However, I will need to use this B to find gamma and alpha. Whenever I need to use the number that I found for further calculation, I will use more decimal places than they asked for so that my answer will be the most accurate. From here, I will need to find alpha and gamma. To find alpha, I can either use law of sines or law of cosine. To use law of sine, I have sine alpha over A equals sine of 30 degrees over B. I have sine of alpha over 10 equals sine of 30 degrees over 6.012812. To solve for alpha, I need first to solve for sine of alpha. So I am going to multiply both sides with 10. And 10 got cancelled out. And I get 10 times sine of 30 degrees over 6.012812. I will put this into a calculator to get the approximation for sine of alpha. First, we need to change the mode to the degree and then type in 10 times sine of 30 degrees divided by 6.012812. And I got 0.83155,76805. To solve for alpha, I will take sine inverse of this number. Again, make sure that the mode is in the degree. And I type in sine inverse of 0.83155,76805. My answer is 56.259,083,523. And the answer asked me to round to one decimal place, so that would be 56.3 degrees. And to find angle gamma, I will take 180 degrees minus 30 degrees minus 56.3 degrees. And I got 93.7 degrees. Example 2. Find the angle alpha for the given triangle if sine A is 20, sine B is 25, and sine C is 18. In this question, they didn't give me the picture, they only gave me the information, so I'm going to draw a triangle. So I have angle alpha, beta, and gamma. Sine A is a sine that is opposite from angle alpha, which is 20. Sine B is a sine that's opposite from angle beta, which is 25. And sine C is a sine that's opposite from the angle gamma, that is 18. In this question, they did not ask me to solve for the triangle. So if they ask me to solve for the triangle, then I need to solve for alpha, beta, and gamma. But they only asked me to find angle alpha. So my only job is to find that angle. Now, I am going to use a lot of cosine. I can say a squared equals b squared plus c squared minus 2bc times cosine of alpha. However, I can use the other variation of law of cosines. If you go back to the previous page, instead of using this formula, I can also use this formula right here. These two are equivalent. The only difference is that this one is solved for a squared and this one is solved for cosine of alpha. In this particular question, I need to find alpha, so I am going to use this variation. Cosine alpha equals b squared plus c squared minus a squared over 2bc. And from here, I am substituting 25 in for B, 18 in for C, and 20 in for A. $25 squared plus 18 squared minus 20 squared is 549. 2 times 25 times 18 is 900. So I have cosine of alpha is 549 over 900. 549 over 900 is 0.61. To solve for alpha, I'll take cosine inverse of 0.61. Cosine inverse of 0.61 is 52.41049,704. And the question asks to round to 1 decimal place. So I have 52.4 degree. Example 3. On many cell phones with GPS, an approximate location can be given before GPS signal is received. This is accomplished through a process called triangulation, which works by using the distances from two known points. Suppose there are two cell phone towers within range of a cell phone. The two towers are located 6,000 feet apart along a straight highway running east to west, and the cell phone is north of the highway. Based on the signal delay, it can be determined that the signal is 5,050 feet from the first tower and 2,420 feet from the second tower. Determine the position of the cell phone north and east of the first tower and determine how far it is from the highway. Round to 1 decimal place. The tower on the left is my first tower, and the tower on my right is the second tower. And the two towers are 6,000 feet apart. The cell phone is to the north of the highway, and that is 5,050 feet away from the first tower and 2,420 feet away from the second tower. The first question. Determine the position of the cell phone north and east of the first tower. So this is my cell phone, and this is my first tower. They want to know if this cell phone is how far east and how far north from the first tower. I want to find the green distance and the red distance. Let's call the red one X and the green one Y. X will tell you how far the cell phone is to the east of the tower, and Y will tell you how far the cell phone is to the north of the tower. In order to answer the first question, determine the position of the cell phone north and east from the first tower, I will need to find X and Y. The cell phone is approximately X feet east and Y feet north of the first tower. For the second question, determine how far it is from the highway. So this is the highway. The cell phone is up here. So in order to find the distance from the highway to the cell phone, I need to find Y. And after you find Y, the cell phone is Y feet from the highway. To find X and Y, I need to use this right triangle with the hypotenuse of 5,050 feet. But in order to use any trig function from this right triangle, I need to have the angle theta. To find this angle theta, I will use the big triangle and the law of cosine. I have the side 2,420 square equals to 5,050 square plus 6,000 square minus 2 times 5,050 times 6,000 times cosine of theta. Or I can have cosine of theta equals to 5,500 square plus 6,000 square minus 2,420 square divided by 2 times 5,050 times 6,000. $5,050 square plus 6,000 square minus 2,420 square, I got 55,646,100. 2 times 50,50 times 6,000, I got 60,600,000. And I will take 55,646,100 divided by 60,600,000. And I got cosine of theta equals to 0.918252472. And to find theta, I will take cosine inverse of this number. And I got theta equals 23.32807,183 degree. The question asked to round to 1 decimal place. So that is 23.3 degree. So I found this angle theta right here. Next, in order to find X and Y, I only need to use this right triangle. So in this right triangle, I have the hypotenuse of 5,050 feet and theta is 23.3 degree. I don't have enough room here, so I am going to add another page and I will show you how to do it on the next page. So this is the right triangle from the previous page. This is the hypotenuse, 50 feet. This is Y and this is X. This is theta. So I found that it was 23.3. However, I will need to use this theta for further calculation. So I will have a couple more decimal places instead of using the rounded answer. So instead of using 23.3, I will use 23.32807 degree. Okay, I need to find X. So this is the angle theta. X is the adjacent. And this is the hypotenuse. So to find X, I need to use the adjacent and the hypotenuse. What trig function that is involved with adjacent and hypotenuse? So cosine of theta will be equal to adjacent over hypotenuse. And to find X, I'll just multiply both sides by 5,050. And that got canceled out. I will put this into my calculator to find X. And I got x equals 4,637.175064. And I want to round it to one decimal place. So that is 4,637.2 feet. Next, I need to find y. Y is the opposite side from the angle theta. And then I have the hypotenuse is 5,050 degrees. What trig function that involves with the opposite and the hypotenuse? That is sine. I will have sine of 23.32807 degrees equals y over 5,050. And to solve for y, I will multiply both sides by 5,050. So 5,050 canceled out. I will have y equals 5,050 times sine of 23.32807 degrees. I will put this in the calculator to get to my answer. And I got y equals 1,999.776844. And I want to round it to one decimal place. That is 1,999.8 feet. So the cell phone is 4,637.2 feet east and 1,999.8 feet north of the first tower. And the cell phone is also 1,999.8 feet from the highway. Example 4. Suppose a boat leaves port, travels 10 miles, turns 20 degrees, and travels another 8 miles. How far from port is the boat? Round to one decimal place. The port is right here, so the boat starts from here. It travels 10 miles up north, and then turns 20 degrees and travels 8 miles. So this is the current location of the boat, and they're asking how far is this boat away from the port. So they're asking for this distance right here. So let's put that in red. They are looking for that red distance. And let's call it A. I want to know what A is. I know the yellow distance is 10. And the blue distance is 8. This angle is 20 degrees. That makes this angle 160. So if I take 180 minus 20, I will get 160 degrees. So I have the measurement of the two sides, and then the angle is in between the two sides. I am going to use the law of cosine. I have a squared equals 10 squared plus 8 squared minus 2 times 10 times 8 times cosine of 160 degrees. 10 squared is 100, 8 squared is 64, 2 times 10 times 8 is 160. So I have a squared equals 164 minus 160 times cosine of 160 degrees. And to find A, I'll take the square root on both sides. When you're taking the square root on both sides of an equation, there's supposed to be a plus or minus answers. However, we're looking for the distance from the boat to the port. The distance will never be negative. So in this case, I will only take the positive answer. And I will put this whole entire square root into my calculator to find A. Square root of 164 minus 160 times cosine of 160 degrees. I got 17.729941323. And the question asked me to round to one decimal place. I will have 17.7 miles. Heron's formula is the formula that is used to find the area of a non-triangle where you are given the size of the triangle. For example, this is a non-right triangle, and I know side A, side B, side C. I will be able to find the area of this triangle by using the Heron's formula. First, I need to find S. S is just half of the perimeter. So if I take A plus B plus C divided by 2, I will have my S. And the Heron's formula say area equals to the square root of S times S minus A times S minus B times S minus C. Example 5. Find the area of the triangle below using the Heron's formula, round to one decimal place. So I have the triangle with given A, B, C. A is 10, B is 15, and C is 7. In order to use the Heron's formula, I first need to find S. And S is A plus B plus C divided by 2. A is 10, B is 15, and C is 7. So I'll just plug them in. 10 plus 15 plus 7 is 32. So I have S is 32 divided by 2, which is 16. So after I found X, I will substitute that into my Heron's formula. I will have S times S minus A times S minus B times S minus C, and then I'll take square root of that. I will substitute 16 in for S, 10 in for A, 15 in for B, and 7 in for C. 16 minus 10 is 6, 16 minus 15 is 1, and 16 minus 7 is 9. So I have square root of 16 times 6 times 1 times 9. And 16 times 6 times 1 times 9 is 864. So I will have square root of 864. And square root of 864 is 29.39387691. And they asked me to round to one decimal place. So that is 29.4.